In this video, we're going to take a look at a simple example of extending classes in Java and how dynamic binding works. We're going to start with an existing vehicle class that has a method called Go, a very simple vehicle class, and we're going to extend it into a class called Sonic. Then we're going to write a unit test that extends another unit test, and we'll take a look at dynamic binding. First, the class that exists is called Vehicle. No big surprises here. It has attributes called miles per gallon, gallons of gas, and odometer. It has getters and setters for each of those. And then it has a method called Go, which simply takes a distance, decreases the gallons of gas by miles driven divided by miles per gallon, and it increases the odometer by the miles driven. Extending a class is actually straightforward. There's a lot more we can do when we extend a class, like override methods and things like that, but simply extending a class and inheriting its methods is easy. I'm simply going to go to my source code, choose Java class, and I'm going to say Sonic. And go ahead and add, and we'll say Sonic extends vehicle. That's it! So at this point, we've inherited everything that's not private in vehicle, and we have a new class. And of course, we can add more methods to it and the like, but we do have a new class. I chose Sonic here because it's a car. It's a fairly basic car. For many, many years, I used the example Cavalier, but they don't make Cavaliers anymore. So Sonic is a car. It goes. Not a whole lot we want to add to it. But of course, as we keep going, we'll find that there are more cars that we want to represent and more classes we can have to represent those cars. Now we want to test our Sonic, and I could alter the driver class and put in a Sonic there, but I'd really rather wrap a unit test around it. Now the question is, we get all these wonderful, great things from extending a class. Can we extend a unit test? Because I already have a unit test called vehicle test. And the answer is yes, we can. We need to make just a couple modifications to it to make it extendable, but yes, we certainly can. Let's take a look. So vehicle test has private vehicle. Let's make that one protected. Remember that word. And then we have our test method. We're going to make that one protected as well. And that means that our subclass that we're going to make has access to this method and can also override the method. As a matter of fact, we could just make all these protected if we want. Generally, we don't want to give too grand access to anything, but this is a small enough class I'm comfortable doing so. So we've made all these protected, which means they can be overridden. I'm good with the test method. That works fine. I'm good with the when because we want to drive our Sonic 100 miles. I'm good with the then because we want to validate the output as it is. But the one that's a bit challenging is the given, because that's where we are creating an object. And remember how polymorphism works. Variable type tells you what method you're allowed to call. Object type, which is what we have here, tells you what's going to happen when you call those methods. Oh gosh, our object type is vehicle, but we actually want to test a Sonic. So what I'm going to do is copy this method, just this method, and then make a new class called Sonic test. Very important, we need to make sure we extends vehicle test. And look right by this line number 1. Look right over here when I do this. Oh, what's that? Well, look. We got a little green arrow which indicates that we can run a test. So you see what happened is the IDE is smart enough to say, okay, I'm extending a class that has a test method, one that's protected at that. Therefore, I am also a test class. And you can go ahead and run me, and it will inherit those protected methods, and it will run them locally. Now remember, if we can inherit a method, we can also override a method and give it any kind of specific behavior. So remember that method that I copied just a moment ago? Let's go ahead and paste it. And okay, all looks good here. And now I'm going to change the object type to Sonic. Now it's time for the great reveal. So we know that we are inheriting most of the test methods, including the one that's annotated with test, but we're overriding one method locally. And what happens when I run this class and it goes up to the inherited method, and then that calls the method we're overriding? Does that invoke the local method in that test class, or does it invoke the overridden method in the class where we actually initiated the test? I've set some breakpoints, so let's find out. Simply right-click and choose Debug. Watch carefully, as right now you notice I started in Sonic test. But you see where the breakpoint went now? The breakpoint went to vehicle test. And, okay, so now we have our overridden method. We have given vehicle has 0 odometer, 15 gallons of gas, and 20 miles per gallon. Now, we know that we have that here locally, and look, the IDE is smart enough to tell us that, oh, by the way, it's been overridden. Now, the question is, note we have method here, we have method call here. What happens when I choose the all-important step into? Watch very carefully. Ah, look at this. Run sonic test. So you see what happens is when we're inheriting a method, and that invokes a method that we're also overriding, it's actually going to go to the method that is overridden in the class where we started this action. That makes sense. So sonic test is where we started the action. It's inheriting the test annotated method. That test annotated method then goes back down into sonic test. It invokes the method that we are overriding. And it knows to do that through the magic of dynamic binding. It's a bit of a confusing word, no doubt, but it's very important. Let's go ahead and finish up the test. I'm going to step over and watch as we finish this method. Watch where control goes. Control goes right back to our vehicle test. And now these other methods are not overridden, so no surprise, it's going to run them locally because we are still inheriting them without overwriting them. So then odometer increases and step into, boom, boom, and we'll finally finish up. And we'll see that sure enough, our test has indeed passed, which indicates that our extended class is inheriting the behavior that it needs from the superclass vehicle. So in this video, we've seen a simple example of extending classes and dynamic binding, which admittedly can be a bit of a confusing topic, but a very important one for object-oriented development. So as always, I hope you found this video helpful, and I look forward to reading your comments. Thank you.